As the holiday season approaches, Jam and I are very excited to announce that we're rolling out another round of merch for the show. We had a great response last time. There were several people who mentioned that they missed out, and we thought it would be perfect in case you know someone who would like this gift for the holiday season. Our classic logo stuff will be back, plus we have some new designs that were commissioned from friends and artists. There's even a special chemistry Christmas tree shirt that I'm really excited about.
Part of the reason we're doing this is also to fundraise. So Melissa and I love making this show and want to do it for a lot longer. But currently we still have some annual fees that haven't been fully covered. Our goal with this merch campaign is that we'll be able to cover the costs of making the show for a whole another year.
To check out our store, go to bonfire.com/store/chem4yourlife. That's chem, F-O-R, your life. Or you can check out the link in our show notes, on our website, or in our social media bio. The last day to buy anything from our store is November 30th. We're doing our best to make sure everyone gets their stuff by the upcoming holidays. So go check it out and help us share chemistry with even more people. And now, on to the show. Hey, I'm Melissa.
I'm Jam.
And I'm a chemist.
And I'm not.
And welcome to Chemistry for Your Life,
The podcast that helps you understand the chemistry of your everyday life.
Okay, Jam, today I'm going to answer a question that you asked on behalf of all parents everywhere.
Yes, I'm so glad.
And that was, how do diapers work?
I'm so excited about this episode. I'm so excited.
Do you have any guesses?
One thing I want to say too is that it's funny because my wife asked me this week if we've ever thought about doing an episode about that. And I was like, I don't know when, but I have formally requested this as an episode. So
nice.
It'll happen soon. And then here we are recording it. So I don't really super have a guess, except that when I texted you that one time to ask you to kind of put this on the queue of episodes, I was looking into, do you know of something called Orbeez?
No.
Okay, Orbeez are like these little tiny things that I don't know where they came from. Like, apparently it's just kids know about them and have played with them, but basically they're like these little tiny water balloons, except that apparently they soak the water up.
Okay.
And so,
yes, I have heard of those.
Okay, so the Orbeez might not be like the technical term; it might just be one of the brands or something. But I was reading a little bit about them, and then someone made a comparison to diapers, and so then I stopped reading immediately and texted you, and I was like,
"Okay,
no need to continue reading this. Whenever we could just talk about it on the show instead, and I could learn it from you instead."
Okay. Well, you spoiled a little bit of one of my fun facts, but that is not far off.
Nice.
But I do think you're going to be surprised at this.
Okay.
So just last week, we talked about nail polish, and you said you thought it was a polymer because it fits into a category of polymers in your minds.
Right.
Well, guess what?
Uh-oh, what?
The way diapers absorb water is by having a polymer in them.
Whoa. Okay, interesting.
And I figured that doesn't fit in your definition of polymer in your mind.
Yeah, not really. It's not really. Yeah. Huh.
So here's the nitty gritty. Okay.
Okay, I'm ready.
So diapers have a polymer in them. It's in its crystalline state. It's a cross-linked polymer. And it has a lot of, remember we talked about functional groups? That's just a collection of atoms that has a similar arrangement of atoms. The same arrangement of atoms it will be known as a functional group. So it has a repeating functional group off of it, this polymer, that is negatively charged.
Okay.
So naturally, this polymer with its negative charge units on it will be closely organized around sodium ions.
Okay.
Let's talk about what an ion is. An atom is neutral.
Okay.
And if it loses an electron, electrons are negatively charged, so what's left behind is positive charge.
Okay.
The absence of electrons leaves you with positive.
Okay.
So these sodium ions, like the same one that would be in table salt, which is sodium chloride, are nestled almost inside of this cross-link polymer web.
Okay.
Organized around the negative charge. So you've got the positive charge from the sodium hanging out nearby the negative charge from the polymer chains.
Okay.
Okay, so that's how it is in its crystalline state. It's nicely, closely packed in a nice crystalline polymer state.
Okay.
It's almost like a powder.
Got it.
But then water, which is the main component in baby pee, hopefully if they're fully hydrated, gets added into this polymer. It will wash away almost. It dissolves the sodium ions. So the sodium ions are more free to move. They're not holding everything freely and tightly. And then the positive charge from water, which has a partial positive charge and a partial negative charge, almost takes the sodium's place, allowing the polymer to expand without ever breaking its bonds. So it can't fully be dissolved by the water. The bonds aren't broken. It's not fully solvated. So instead, it becomes this big gel, clumpy mess.
Oh. Huh.
So it expands to hold that water without the bonds ever breaking. So the water can't just be released back the way it does in a sponge. And that's how diapers hold on to pee.
Weird.
So I try to think about a good, I guess, story for this, or a good analogy.
Okay.
And the best thing I could imagine is if your two fists are the polymer and you interweave your fingers together, and you're holding a really tight thing in there, like a pool ball. Yeah. It's hard. Your fists, or if someone tries to poke them, it's not really going to work.
Yeah.
Because they're going to have a hard ball in the middle of them. But if you put a water balloon in there instead, it's going to be a lot more loosey-goosey wiggly. And if it's a bigger water balloon, your fists will expand to hold on to it.
Right.
And that's essentially what's happening here with the polymer. When it just has sodium ions, it can get closely packed. It's hard and tight. It doesn't have a lot of the wiggle room. And then the water comes and replaces those sodium ions. Your fists aren't so hard and tight. They're sort of spreading out, and they're a lot more wiggly. And that's why the consistency goes from a powder to a gel.
Wow. Wow. Interesting. That's a helpful image to have, that analogy.
Yeah, I think it's pretty hard to visualize the idea of polymers absorbing and bonding to new things and sort of spreading out. But you can visualize your fists. So that was the only thing I could think of that sort of did something similarly.
Yeah. This is really weird. It is a lot weirder than I would have thought, especially trying to fit it in with what's been so far normal about polymers, the situations that we've seen them in our everyday life. This one is very much not the same.
Totally different. It threw you for a loop. It's a new application of polymers for you.
Gosh, that's crazy. Okay. Should I try to tell it back to you? I don't think I can come up with a better analogy than the fist and water balloon thing.
Yeah, maybe I shouldn't have stolen it from you.
Well, it's okay. I mean, I think I kind of needed it to understand.
Yeah, definitely. Lay it on me.
Okay, wait. Ions positive, right?
These are positive ions.
These are. Oh, ions aren't necessarily positive.
No, cations are positive, anions are negative. Ions are just ions.
Ions is the overall word. And
for charge.
Got it. Okay, so in the diaper, in the secret compartment layers of the diaper, in the black box that we call a diaper, there is this granular stuff. This powdery looking kind of stuff.
Yep.
It's a polymer that has a sodium ion in it.
It has a lot of sodium ions in it.
Lots of sodium ions in it.
Mm-hmm.
Okay. And it could almost be like, rather than just being all one big net, it's like each thing could be like, it's a tiny little net that allows things to kind of come in and out of it. Like obviously nets have holes in them.
Mm-hmm.
Whenever baby pee, which I loved how you said earlier, like baby pee is mostly made of water. It was like, it's almost as if you were describing any other like chemical or something. Like chlorine is mostly made of baby pee. So baby pee, which on the periodic table is number 199, is mostly water. And so when the water goes and fills up the diaper, starts going into the polymer and sodium ions, it dissolves the sodium ions into it, which basically frees up the middle of all these tiny nets. It gets in there, and what's crazy, which doesn't quite work exactly in the analogy, is that somehow when it gets into all these nets, it stays in there somehow. The polymer can get bigger a little bit and stay connected like a net would. And it can hold all this water that's coming in. And rather than just being like a balloon where there's like a free-flowing liquid in there, it's like tons of this going on at a really small scale. So it's like not like all these water balloons. It's more like just now it's a gel. Like just like we'd have with something like aloe vera or whatever, where it's like a really thick, like gel kind of substance, rather than being tons of like water balloons or something.
Yes, exactly. And the way it stays in there, this is different from a net, but the way it stays in there is water also is made up of oxygen and 2 hydrogens. And it's not evenly distributed electrons all around that. The oxygen pulls some more electrons towards it, leaving the hydrogens slightly positive. So they fit into the same spaces that the sodium ion does with the positive part of the water molecule. So that's how it gets trapped, is it basically just dissolves the sodium. So sodium likes to be in water. And then the water that's left will bind back to where the sodium had been bound before.
So it's binding, which is why it changes the consistency a little bit of what the end product is. Instead of just being like a water droplet kind of nestled in with all of these powder grains or whatever, it changes the consistency of it because it's, what would you say, linking up with the polymer?
I'm not sure if it's a technical chemical bond or if it's intermolecular forces, but there is an attraction for sure between the water molecules and the polymer.
Got it. Okay. Man, dude, this is it's like a little bit hard to wrap the head around.
It is. Another good way you could think about it would be maybe the nets have, if nets had something in them just laying, if you had a net laying on the deck of a boat and it had some stuff in there, well, but nets don't hold water. It's tough.
Yeah.
It's tough.
Dang it. Gosh, dude.
If you filled a net up with water balloons, there you go.
Okay.
It would expand. It would still be a net. So it's not like the water balloons would just be everywhere. It'd expand and have a different overall feel. But it still has that jelly water-like consistency, sort of. But it's not as if water's just freely flying in and out of the net.
Yeah.
Comes into the net and gets trapped.
Yeah.
Maybe that's a good one.
And it likes to be there.
Okay. So that is the basics of how a diaper absorbs water. But I have some fun facts for you.
Yes, please.
Now that you've explained it back to me. So I forgot to mention the name of this polymer that's super absorbent is called sodium polyacrylate.
Okay.
Sodium for the sodium ions. Polyacrylate is the negative part of the polymer.
Okay.
And sodium polyacrylate can absorb 300 times its weight in tap water.
Whoa.
Tap water has some other salt ions in it.
Mm-hmm.
So it has some things that are competing for those negative charges. So if you get deionized water with absolutely no salt in it,
Mm-hmm.
sodium polyacrylate can absorb 800 times its weight.
Oh my gosh.
In water.
Dude, that is so crazy.
And this is part of a class of compounds known as super absorbent polymers.
Mm-hmm. Interesting. Gosh, dude.
Mm-hmm.
Let's cut some diapers open, you know?
Well, it's funny that you should say that because I'm thinking that is going to be our next activity for Chemistry for Your Life at home.
Nice.
Yeah, what can I say? Also, this same technology is used for those absorbable toys, the ones that can grow when you put them in water. So you called them Orbeez, but I had little tiny Martian men that we would soak in water and they would grow several size bigger.
Oh, yeah. I think we actually had some of those too as kids. Like the consistency is kind of different because Orbeez end up looking a lot like little water balloons. But oh, yeah, I didn't think about that. Those little dudes.
So those are the same. But I did read an article in the journal Pediatrics that indicated that those are pretty dangerous to have around kids because they can swallow the small Orbeez and in your body absorb water.
Ooh.
And so actually there's a scary story of a little kid who had to have surgery because of the it wasn't Orbeez brand, but it was a small marble-like ball that absorbed to a much larger ball and it had to be surgically removed.
Yikes. Dang, dude, that is scary. Yikes.
So PSA to parents out there. And this technology is also used to release water into soil. That's originally how they developed these, was looking into how to have something that could give water back into soil, like soak it in, hold on to it, and then give it back. And it's used in cosmetic properties like hair gels.
Oh, interesting.
So all over the place.
Yeah, seriously. That's crazy.
And that's how diapers work.
Dude, thank you. Now I know. I have changed
every time
so many diapers.
Every time you change those diapers, you're going to say, thank you, chemistry, for absorbing all this baby pee.
I'm sure that my kid will love hearing that every single time, multiple times a day.
Yeah, I think as a child, I'd be happy to hear that 6 or 7 times a day.
Yeah. And there's definitely times where I've been impressed at how much the diaper has held. So like maybe like his diaper he wore overnight or something. And I'm like, dude, this thing is packed with some baby pee.
Yeah. And it theoretically could hold even more if the pee has a higher component of water and a lower component of salts and other things present that will be competing.
Right.
So that's crazy to think about.
Dude, for real. Very impressive.
Well, don't worry. We're going to cut into some diapers and do some experiments with them just as soon as we possibly can.
Okay, sweet. Dude, I'm ready. I'm definitely interested in doing that.
I will say, too, I looked up the safety of this molecule, this polymer, on a safety data sheet, so not on a biased source. And it said it can really irritate your mucous membranes, which is anything like your eyes or your mouth that has a high water content. And that makes sense because it can absorb the water. So that is going to irritate it because it'll soak up the water. So you don't want this to come into contact with your eyes or your mouth or your nose.
Okay.
And try not to inhale it or anything like that.
Got it.
And it can be a mild skin irritant, but usually just soap and water, wash with soap and water. If it comes into contact with skin, will take care of it if it's irritated. So it is a non-toxic substance.
Interesting. Good to know.
Yeah, so it's safe, should be safe to use on babies, should be safe to use in whatever context it's currently being used.
Got it.
As long as you're not breathing it in or rubbing it in your eyeballs.
Got it.
Okay, so now we're at the part where we talk about our weeks. And what I'm going to talk about instead is my next 6 weeks.
Okay. That's cheating.
Okay,
so that means you can't share one for the next 6 weeks of episodes.
So what I decided to do was look at my next 6 weeks, which ends up being around December 17th, and figure out every major task I need to do between now and December 17th. Thinking I would be really overwhelmed, but I actually think I'll be able to get all of my work done in that time. Jam and I are going to be able to, don't worry, we're going to still put episodes out, but we're going to take a 2-week break from recording. And I think I'll get at least a week and a half off from work in between the semesters before the new semester starts.
Nice.
I'm very excited. I need to work a lot and get a bunch of stuff done. I may still work a little bit, but I will not have any urgent tasks over my break, which I'm very, very excited about.
Yeah, that is awesome, dude. Very cool.
And things were a lot closer than I realized. So I only have 2 more chapters to teach in the class I'm teaching, which we get through 2 chapters in 2 class periods. So that's pretty quick. And I only have 2 class periods per chapter. And I only have about 3 more assignments in the course I'm taking, which is a lot less than I thought.
Yeah.
So it's just things when I laid it all out, when it was feeling overwhelming and like I had a lot to do, when I laid it all out, it didn't seem as bad. It seemed a lot more manageable.
Dude, yeah, that's a great idea. Really like helps zoom out and not feel a little bit like, daunted by the unknown. But it's like, oh, hey, I just mapped it out and it's doable.
And if I'm working on one of these tasks at any given time, then I'm being productive. So that's nice.
Yeah. That's great.
What about you? What's your week shaping up like?
So for me, I feel like I've kind of hit an interesting point in terms of work stuff where for a long time, and I'm sure many, many freelance type folks out there know exactly what I'm dealing with too, but have basically been saying yes to everything. It's like anyone who will hire me for stuff, it's like just take as much on as I can, because especially starting out, it's like you're trying to fill up your schedule and have more to do and obviously make more. And I'm at a point now where I think I need to start saying no to stuff and to even taking some things off my plate.
Yeah.
Because I have a little bit of an idea of like, okay, I like some of these things more than others, or I have an easier time kind of meshing these things with my schedule than other things. And I think I'm realizing that just a little late, to a point where I have more on my plate a lot of times, a lot of weeks than I wish I did.
You're a little overbooked.
Yeah. I feel like September wasn't quite that way. And then late in September, and then pretty much all of October was like that. And so I'm making some decisions about how to remove some stuff, because like just you just saying that you're going to have like a week and a half off in December from work, I was like, oh man, I don't know when, if ever, I would get any time off.
Oh no.
And obviously that's the downside of freelancing. You gotta
have some time off.
Yeah, and that's one of the downsides of freelancing, is that you have to give it to yourself and know that that means you're not making anything during that time.
Right.
Unless you like took on more stuff before that or played catch up afterwards. So that's just, comes with the territory. But that's one of the things I'm trying to think through now and make some decisions about. So it's not a happy thing. It's just sort of a state of Jam's Union address.
Well, that's really exciting that you're getting a lot of work, that you get to be choosy. That is a much better situation than feeling as if you're not making ends meet and you're not getting enough work.
Yeah. And yeah, for sure. It's definitely a better place to be than being like, okay, I'm twiddling my thumbs. Will someone please pay me to do something? So definitely better place to be.
So hopefully you can figure out how to manage that a little bit better. And your update in a month or 2 is that you took a bunch of time off and you are just somehow making all the dough.
Yeah.
Well, that's exciting that you have a lot of interest in your business, but also I know it can be overwhelming to have so much work. So thanks for taking time out of your work day and out of your freelance to and record our podcast and edit it and make it sound incredible. We have the best sound quality thanks to you, Jam. And thanks for learning about and asking about how diapers work. You are responsible for so much of this episode, so thank you so much.
Anytime, and thank you for teaching me and us, and on behalf of all the parents out there who have scratched their heads about diapers, we salute you.
Well, maybe not me, but maybe chemists who made the diapers.
Chemists, that's true. You did remove the shroud of mystery from it, so
right.
It does feel like we owe you thanks, but also thanks for people who invented it, for sure. That you guys are the real MVPs.
Yay, chemistry for making parents' lives easier.
Absolutely. So Melissa and I have a lot of ideas for topics of chemistry in everyday life, but we want to hear from you. Ideas like this, something like that. It's diapers every day. Parents are dealing with diapers. So if you have ideas or questions like that, please reach out to us on Gmail, Twitter, Instagram, Facebook at Chem for Your Life. That's Chem, FOR, Your Life, to share your thoughts and ideas. If you'd like to help us keep our show going and contribute to cover the costs of making it, go to ko-fi.com/chemforyourlife and donate the cost of a cup of coffee. If you're not able to donate, you can still help us by subscribing in your favorite podcast app and rating and writing a review on Apple Podcasts. That also helps us to be able to share chemistry with even more people.
This episode of Chemistry for Your Life was created by Melissa Collini and Jam Robinson. References for this episode can be found in our show notes or on our website. Jam Robinson is our producer, and we'd like to give a special thanks to V. Garza and A. Collini, who reviewed this episode.